Okay guys, let's talk about basic trigo identities. Yeah. So first, let me show you how we actually derive this trigo identity. There are three, but the first thing is we can go through this again. So we know if you draw a right angle triangle, this is the right angle triangle. Let's say the length of one side here is x, this is y, and the hypotenuse is r. So we know that x squared plus y squared is going to give us r squared. So when you divide everything by r squared, you can write extra step here, x squared, r squared, y squared over r squared. The result is 1. Now you factorize it, you get something like this. And if I read from this triangle, sine is the opposite over hypotenuse, sine is y over x, cos is adjacent over hypotenuse is x over r. So we can sub inside. This will be x over r will be your cos square, this y over r will be your sine, so it's sine square. You get cos square plus sine square equals 1. So this is a very important formula. You can highlighter, color pencil, watercolor, crayon. Yeah, okay, sorry, this is stood up, you can't see. So now, if I take this equation, I divide everything by cos square divide cos square, I'll get 1. Maybe I write extra step here, cos square theta divide by cos square theta, and sine square theta divide by cos square theta. So this is going to give us 1, and sine over cos is going to give us tangent, and 1 divided by cos square is going to give us secant square, right? And if I take this equation here, the equation here, and instead of divide by cos, I divide by sine square. Now we know that cos square divided by sine square here, this is going to give us what? Cotangent. Cotangent is cos over sine, and then you plus sine square divided by sine square. This is going to give us 1. Oh, sorry, I think I've accidentally moved this up. Okay, over here. So, and then lastly, 1 divided by sine square is going to give us cosecant square, which is here. Okay, so here we have 3 new formulas. So how do we remember so many formulas? So there is a method to do that, to remember this formula. We call it the hexagon diagram. So now in the hexagon diagram, maybe I can show you here. I can draw it again, right? It's over here. Maybe I just draw it again over here, and then we're going to rub this off. So if you imagine you're having a hexagon like this, this is a regular hexagon. The middle one is a circle with a value of 1, and the rest are like this. But you got to start off with T, S, and C, tangent, sine, and cos. So we know that 1 over sine is cosecant. So you move across here, this will be cosecant, right? You can put a theta if you want. Now you move across, 1 over cos is going to give us secant, and 1 over tangent is going to give us cotangent, right? Now there are 3 applications of this hexagon diagram. The first one is this. If you go in any direction, say clockwise direction, we always take the first equals second divided by third. For example, my first variable is tangent. First function is tangent, so we write tangent theta equals, if I go in clockwise direction, what is the next one? Sine. The third one is cos. Now we can go the other direction. Let's say if I start from cotangent, I go this way. So the first one is cotangent, second one is cos, third one is sine. So basically cotangent is cos over sine. Now you can actually go any way. You can say tangent is secant divided by cosecant. You can say secant is tangent divided by sine. Cotangent is cosecant over secant. They all work, but we don't need to know so many. So basically these 2 are the important one that we need to know. So when you go clockwise and clockwise, the same thing. It's always the first equals second divided by third. The second application is if you go opposite, that I've already mentioned to you. Sine, 1 over sine is cosecant. So you can write cosecant is 1 over sine. It's a reciprocal function. Okay, the second one will be, you go across here, secant is 1 over cos. Okay, and the third one is cotangent is, keep moving up and down. So sorry, it will be okay over here. So cotangent is cotangent is 1 over tangent. So the third one is over here. Can you see? You go across. Alright. Now also you notice I actually shaded this part because these 3 parts here represent the basic identity formula. The first one, now it doesn't matter whether you go right to left or left to right, but most of the time they actually arrange from left to right. That is, they write cos square first, alright, here cos square, then you plus sine square, which is this, and the result equals to 1. Can you see that? Yeah, like a radioactive symbol thing. And then if I start from 1 here, I plus, can you see this? Tangent square. The result is always the one below. What's the one below? Secant square. And if I start from cotangent, I plus 1, 1 is over here. You move down here, what do you see? Triangle here? Cosecant square, right? Okay, so that's how you apply, or the hexagon diagram to derive all this formula. Okay, so can I just go on now? Okay, I'm just going to erase this. I'm going to show you example number 41 now. Okay, oh, this is a lot of erasing to do. Okay, all right, so in example 41, when it comes to proving, this is the formula that you need to know, but there's a I would say a guideline to actually decide what to do when it comes to proving. Number one, we always start with the side, the left and right hand side. By the way, this is called the left hand side is called the LHS, the short form. Right hand side is RHS. So we always start from one side and move towards the other, and we always start with the side with more number of terms. More number of terms means you have more, like a plus b is considered 2 terms, a times b, a divided b is considered 1 term. So you can see the left hand side is more complicated, has more terms, has a minus here, whereas the right hand side has only a single term, the multiplication. Multiplication is considered 1 term, so just so you know. Okay, so we're going to start on the left hand side. Okay, but then what do I do? What can I do? Well, from the basic identity, we know cos square plus sine square equals 1. So this is one of the very, very important formula that I hope you can remember, because it's going to help you a great deal. That is, when I bring over 1 minus sine square, I'll get cos square. Now, likewise, if I bring my cos square over, then I'll get sine square, and sine square is always 1 minus cos square. It's always the reverse. Yeah. So we know we can always change the one with square, and in this case, 1 minus sine square over here, we change to cos square. And at this stage, if you're not sure, have a look at the right hand side. Right hand side, you have tangent. Now we know tangent is sine over cos. So what I can do is I can split this into 2, right? The cos square over here, I can write as cos times cos, right? So now this will be tangent x, and 1 over cos is actually secant x. This will give us our right hand side. Okay. How about part B? Okay, if you look at part B, again, the one that is more complicated is my left hand side. Okay, so I have secant and cos. Secant is 1 over cos. There's another cos here, right? So how do you simplify fraction? So whenever you see double fraction like this, what we can do is we can just multiply top and bottom with cos. So when you multiply the numerator with cos, you just get a single cos. The reason why I multiply this cos, because I want to get rid of this cos over here. I'll highlight this for you. I'll get rid of this cos. So when I times over, it's going to give us 1, and this will be cos square. And like I said earlier, 1 minus cos square is what, everyone? 1 minus cos square is sine square, right? And if you're unsure what to do, have a look at the right hand side. You have cotangent here. So we can break this up to cos over sine. That's going to give us cotangent. And this sine square, I break it up to sine times sine. So cos over sine is cotangent, 1 over sine is cosecant, and this is my right hand side. Okay? Alright, moving on to self-test. So in self-test 41, okay, if you look at part A, we start from the left hand side, since left hand side has more number of terms. And remember, 1 minus cos square, we can convert it to sine square. So this is sine square. Then you divide by tangent. Okay, sorry, this is supposed to be theta, not x. Okay, so just take note of that. So next thing is, what do you think we can do with tangent? Well, in fact, I should cut short my working. You don't have to write extra step. But tangent is actually sine over cos. Right, again, you've got double fraction. Maybe it's better for me to switch this up. But remember, when you multiply up, you basically invert it upside down. Well, is this easier for you? As we cancel sine square and sine. Notice we can cancel this sine square and sine. So you're left with sine theta, cos theta, and this is the same as your right hand side. Okay, now for part B, okay, now we have cosecant square theta minus 1. So actually you have two ways. You can change everything to sine and cos. You can also use the third formula for what do you call that? Basic identity. Yeah, so up to you. Okay, maybe I show you the first one. Okay, method one is I just change cotangent to cos over sine, because every time you are not sure what to do, you can always change to cos and sine. It always works. Yeah, you can always simplify from here. Then I multiply top and bottom with sine square. Now multiply by sine alone is not enough, because the term that you have over here is sine square. So I want to get rid of this. We can get rid of this by multiplying top and bottom with sine square. Now, once you've done that, you're left with cos theta, sine theta. Take note, these two I can cancel, right? Okay, and once you cancel the denominator, this will give us what? This will give us 1 first. Sorry, this is 1, and this will be sine square. Okay, what is 1 minus sine square? 1 minus cos square is sine square. 1 minus sine square is cos square. So this is going to give us cos square. As I can cancel cos and cos square, I'm left with sine over cos, and sine over cos is tangent, right hand side. Okay, now some of you can remember that the third formula is cotangent square theta plus 1 equals to cosecant square theta. Yeah, if you can remember that, we know cosecant is what? Okay, let me write down, start from the left hand side, not right hand side, sorry. Change this. We start from the left hand side. Okay, my cotangent I keep first, but I know cosecant square is cotangent square theta plus 1. Then there's a minus 1 here, you minus 1. So you're left with cotangent theta over cotangent square theta. So when you cancel, you get 1 over cotangent, am I right? You just flip this up, you get tangent. Oh my god, this is so much easier, am I right? But provided you remember the formula, remember how to apply the formula. Actually, this formula is given in exam. But most of the time, we just remember the first one, sine square plus cos square equals to 1. All right. In fact, if you just remember the first one is sufficient for you to solve all the problem. But if you can remember this, okay, maybe it will come in handy. Yeah? So we sub inside here. Yeah, the working is way shorter. All right. Okay, let's move on to example number 42. So now in this example, you're given secant A cosecant A minus tangent A is equivalent to cotangent A. Yeah? It's a May June 2008 paper. So all these are past year questions that are cloned, so you can you can actually, when you're doing past year, you can actually refer to the particular year. It's about the same. Okay, so let's start from the left hand side. Now why left hand side? Left hand side has more number of terms, and secant is 1 over cos. Cosecant is 1 over sine. Tangent is sine over cos. Right. So now you notice if I put this together, right, my common denominator over here is cos A sine A. Right. So this is 1. But on my right hand side, I am short of something. I am short of sine and sine. Can you see that? I'm short of sine and sine. So that I have to multiply top and bottom with sine so that I can combine this to a single fraction. And what is 1 minus sine square? 1 minus sine square is cos square. So this is cos A sine A. So when I cancel, I get cos over sine. Now what is cos over sine? Have a look at your right hand side. Isn't it cotangent? Cotangent A, and this is my right hand side. Okay, now if you look at the second part B, yeah, okay, again we start from the left hand side, yeah, because left hand side has 2 terms, right hand side has a single term. Cosecant is 1 over sine. This is a single sine, okay. Then what I can do, again, I'm short of something. What is that? I'm short of sine here. When I write sine means sine over 1, so I must multiply top and bottom with sine, so that I can get 1 minus sine square over sine A. And you're quite good at this by now, right? We know 1 minus sine square. Everybody, 1 minus sine square is what? 1 minus sine square is cos square, right? So we can change this to cos square straight away. You divide by sine A. Now I need to split this into two because I can see this is cotangent over here. So cotangent is cos over sine. And when you break this up, there's another cos here. Cos over sine is cotangent, and there's a single cos on the right hand side. So there you go. That's my right hand side. All right. Okay, let's move on to self-test. In this self-test, if you start from the left, we know we have to start from the left because left hand side has more number of terms. My tangent is sine over cos. Okay, and we'll just keep the cos x here. Now again, you notice that I need to multiply top and bottom here with cos because my denominator over here is a single cos. So I multiply top and bottom by cos. So we can put this together. Sine times sine is sine square, right? This will be cos square. My denominator is just a single cos. And we know sine square plus cos square is going to give us 1. And this is from the basic identity. And we have 1 over cos. And 1 over cos is the same as our secant x. This is our right hand side. For part B, let us start from the left hand side. Okay. Now, what I can do is I change tangent to sine over cos. I change cotangent to cos over sine, right? And we can cross multiply. Sine multiplied by sine is sine square. Cos multiplied by cos is cos square. Let me show you this way so that you can understand. So I need to cross this way and these two multiply together so that I can combine everybody to a single fraction, and this is cos x sine x. Now we know sine square plus cos square is 1, so you're left with cos x sine x over here. Okay, now but when you look at your right hand side, what is missing? I have cosecant and secant. So cosecant is 1 over sine and secant is 1 over cos. So I need to split these two and rearrange it. So perhaps I put 1 over sine here first and 1 over cos x here. So 1 over sine is cosecant, 1 over cos is secant, and this is therefore my right hand side. Yeah, always work from the left, work towards the right. If you're not sure, have a look at right hand side, identify what you have here. So yeah, and work towards that. All right. Okay, move on to example 43. Now in this example, we have fraction on the left hand side. Okay, so obviously we have to cross multiply. So we multiply over 1 plus sine, multiply 1 is still 1 plus sine, right? 1 minus sine multiply over is 1 minus sine. And your denominator, put it together as 1 minus sine, 1 plus sine. Now we know that a square minus b square, sorry, should I write this first? A plus b, when you multiply a minus b, you should get a square minus b square. So that's what I'm going to do in my denominator. By the way, your numerator can cancel these two. The sine and sine here, cross it off, right? So you're left with 2. My denominator is 1 minus sine square. And what is 1 minus sine square? 1 minus sine square is cos square. As I bring it up, remember 1 over cos is secant. Since you have a square here, it's going to be 2 secant square a. Yeah? And this is the same as your right hand side. Alright? Okay, for part B, I have cotangent. We can change to cos over sine. I can't do anything with this. First, let me copy this equation, right? I think red pen is better. The blue is a bit hard to see, right? So I'm going to cross this way, right? So that when I multiply here, I'm going to do a bit slower. Okay, faster. Cos times cos is cos square. Minus 1 times cos is cos a. Sine multiplied by sine is sine square. Then these two, I'm not going to expand it, so I'm going to keep it here, right? Because how do I know whether I have to expand or not? I look at my right hand side. I have a single cosecant, and cosecant is 1 over sine. So I can see I must maintain the sine on my right. I must maintain this. So I don't want to expand the bracket. Let's just leave it first. And next thing is, we know cos square plus sine square is going to give us 1. So I'm going to just write this as 1 minus cos, right? Okay, and then you can see there's something that we can do. Okay, I just want to write extra step for you. You either factorize the negative on top or factorize the negative below. Both ways also can, as in, let's say my numerator I take out negative. I'm left with cos A minus 1. This is sine A. This is still cos A minus 1, right? So I can cancel them off, and I get 1 over sine. And what is 1 over sine? There's a negative here. Negative cosecant A, which is exactly the same as my right hand side. Okay? Okay, in self-test 43, similar concept. So we know we have to cross multiply. So in this case, you multiply these two together, these two together, these two together. So let's get straight to this. Left hand side, sine multiplied by this is going to be sine theta plus sine theta cos theta. Whereas the second one, if you multiply, you get sine theta minus sine theta cos theta, and my denominator will be 1 minus cos theta multiplied with 1 plus cos theta. Okay, the next thing is we can cancel these two off. You can see here, sine cos. One is positive, one is negative. So when you cancel off, you're left with 2 sine theta. And my denominator is 1 minus cos square. And what is 1 minus cos square? 1 minus cos square is sine square. As we can cancel two of them, you're left with 2 over sine. And 2 over sine is 2 cosecant theta, right hand side. Okay, not that difficult. So with more practice, you may find this is okay lah. Trigo proving is not that hard after all. So let's move on to the second one. If I cross over here, right, and the denominator you times together, of course. So you will get cos times cos, which is cos square. Now for this, I think it's better for me to write in the bracket form first, easier to understand. And for cos theta 1 plus sine, I just put the cos in front, the 1 plus sine in the back. You can do the other way around, doesn't matter. Next step, let us expand this. This is in the form of a square plus 2ab and b square. Okay, keep my denominator cos theta 1 plus sine theta. Alright, now what can we do with cos square and sine square? You add them out. Cos square plus sine square is going to give us 1, right? So just write extra step for you. Then your denominator is cos theta bracket 1 plus sine theta. So these two we put together is 2 plus 2 sine theta. And you have cos theta 1 plus sine theta. So we can see that there's a common factor here that we can take out, 2 and 2. When you take it out, you're left with 1 plus sine. As for your denominator, you just leave it first. We can cancel these two, right? So once you cancel, you're left with 2 over cos. And what is 2 over cos? 2 secant theta, which is your right hand side. Alright, can you see? Alright. Alright, let's move on to example 44. So if I start from my left hand side, you can see left hand side looks a little bit more complicated because you have a bracket. Yeah, you have a fraction and bracket, sorry. So if I start from my left hand side, we can expand this. This is going to give us a square plus 2ab, 2 sin x cos x, and b square, which is cos square. Negative, if you square it's still positive. So actually this is quite easier because you can see that you have a sine square and a cos square. Then we can just add up. So when you add up sine square plus cos square, it's going to give us 1. And I just have to copy this over here to sine x cos x, and there you go. This is the same as your right hand side. Yeah, pretty straightforward. Okay, but the second one looks a bit more complicated. So again, you have a few options. Maybe I use the formula because I can see this is a plus and a minus. So we can change this to cotangent square minus tangent square. Yeah, a plus b, a minus b. When you expand, you get a square minus b square. Now, if you remember the basic identity, we have 3 formula. The second formula looks like this: 1 plus tangent square is secant square. Because I can see my right hand side I have secant, so I know I have to change to secant, right? So we know that secant, we know that we have to make tangent square as a subject, so it's secant square x minus 1. Whereas the another formula, sorry, I don't have space, I'm going to write here, cotangent square x plus 1 is cosecant square x. So cotangent square, on the other hand, we can change to cosecant square minus 1. So I'm going to replace this formula into this two here. So cotangent is cosecant square x minus 1. Tangent is secant square x minus 1. So when you multiply inside, the negative 1 minus 1 is just going to cancel each other out. And this is the same as my right hand side. Okay? Okay. Now, if you think this is like you cannot remember this, you can always change everything to sine and cos. Now we know cotangent is cos over sine, right? Tangent is sine over cos. Okay? And another cotangent, cos over sine, and sine over cos. But this second one is going to be a minus. It's going to be a minus. So, okay, we can put them together. This is cos square x plus sine square x over sine x cos x. This is going to be cos square x minus sine square x over sine x cos x. But this method is a bit long. We know cos square plus sine square is going to give us 1. And this is cos square x minus sine square x. Whereas these two, when you multiply together, you are going to get a sine square and a cos square. So what we had to do is to split them into two. Sorry, I'm running out of space. So when I split to 2, right, this cos and cos square can cancel, left with 1 over sine square, right? Sine square can cancel, 1 over cos square. And that will give us cosecant square x minus secant square x. Yeah, you may say method 1 is much easier, provided you can remember the usage of the second and third basic identity formula. Alright? Okay, let's move on to self-test 44. Now, here we have secant theta plus 1 and minus 1. So I think we can use the expansion of a minus b, a plus b. So the secant square theta minus 1. And this is really straightforward because we know, you go back to the formula, tangent square, should I say 1 plus tangent square is secant square? Remember this? Second formula for basic identity. So I can substitute 1 plus tangent square here, minus 1, you get tangent square, and this is exactly your right hand side. Okay, for part B, now I have 1 plus cosecant. Cosecant is 1 over sine. Yeah, I have 1 minus sine over here. Keep it first. Right. Then we can combine this as a single fraction. This is sine theta plus 1 over sine theta. And this is 1 minus sine theta. Now I see sine theta plus 1, we can actually rewrite as 1 plus sine. Am I right? It's the same thing, right? Now I purposely write this step for you so that you can see and understand that this is in the form of a plus b, a minus b, so that when you expand, you get a square minus b square, 1 minus sine square. So, and what is 1 minus sine square? Cos square, right? And if you truly think of right hand side, what is on your right? Cos. So write this as cos theta multiplied by cotangent is what? What is cotangent? Cos over sine, right? So this is cos theta, cotangent theta, which is my right hand side. Okay. So let's move on to example 45. Now this one is about simplifying the expression, and not proving, but simplifying the expression so that we can find the value of constant. Okay, it's a past year question, October, November 2011, paper 1, variant 3. Of course, I clone the question and make it a little bit different. Yeah. So we start off from okay, sorry, I have this bad habit of writing left hand side. No, we don't have to write that. We can straight away start from this equation. Now I'm going to copy the question. So straight away, I'm going to take out 9, right? There's a 9 here. This is 1 minus sine square. All right. Now, how about cosecant? Cosecant, you can choose to change to 1 over sine, but I think it's not necessary. we know that cosecant, okay, let's go back to the formula. 1 cotangent square theta plus 1 is cosecant square. So we can change to cotangent if you want. If you can also change 1 over sine if you want. So up to you. What do you think? I'll just use this for now. So this is cotangent square theta plus 1 minus 1. So the 9, you can actually take it out because this is square root of 9. And what is 1 minus sine square? Is cos square here. And this is cotangent square. The 1 minus 1 can cancel out. Now, square root of 9 is 3. Cotangent, if I invert it, it becomes what? Okay, maybe I square root. I give you a square root first. A square root is a bit annoying, right? Just square root the whole thing first. So I'm going to write this as a cos over cotangent. Yeah, because we can actually cancel them out, the square and square root. So cotangent, if you flip it up, becomes sine over cos, right? I say this again. Cotangent is cos over sine. But because you have 1 over cotangent, basically they're just tangent. I invert this, becomes sine over cos. And as I can cancel cos and cos, so I'm left with 3 sine theta. And therefore, what is your k? K is 3. Alright? Okay, let's move on to self-test 45. Now I can see that I need to simplify this whole expression to this form, k cosecant theta. So maybe we just keep the sign, don't do anything with the sign. Simplify the fraction, the bracket first. This is 1 plus cos plus 1 minus cos. And these two put together is 1 minus cos square. Guys, I cut short my working. You already know this. We can times together. This is in the form of a minus b, a plus b. When you expand, it's a squared minus b squared. So the next thing is the cos and cos, we can cross them out, right? So 1 plus 1, stupid question, is 2. 1 minus cos square is sine square. Now again, we can cross out the sine and sine square. You're left with 2 over sine. But the answer must be written in this form, cosecant. So just flip it up. 1 over sine is cosecant, right? And therefore, you got this answer already. Just find the value of k. My k is 2. Okay, let's move on to solving trigo equation involving basic identities. So now, remember, when you want to solve a trigo equation involving cos and sine, like in this case, you can see involving cos square and sine square, you always change the one with square. Now, going back to basic identity, cos square plus sine square is always 1. So if this is y, I'll just write this as y. So therefore, cos square is 1 minus sine square. So the one with square is the one we have to change. So in this case, is 1 cos square here. I change to 1 minus sine square y. And this is sine y plus 1. So as I multiply this inside, now what we have here is a quadratic equation involving sine. So we can rearrange as sine square, 2 sine square y plus sine y minus 1 equals 0. Double bracket factorize it. So this will be 2 sine y minus 1 and sine y plus 1. Now, here we know sine y is either half or negative 1. For sine y equals half, we use a calculator. Yeah, you know by now, right? When you find a reference angle is 30, sine is positive in quadrant 1 and 2. Quadrant 1 is 30. Since this is in degree, so quadrant 2 is 180 minus, so you have two answers, 30 and 150. For sine y equals negative 1, the easiest way is to use what? 1. If you get 1, negative 1, and 0, we always use a graph. The graph is the easiest way to find. So at negative 1, your angle is 270. Okay, so 1, 2, 3 answers. Okay, how about the second one? Now, the one with square for the second one is sine square. Now, we know sine square is 1 minus cos square. So I'm going to substitute inside 1 minus cos square into here. Okay. Next, I'm going to multiply inside 4 minus 4 cos square y plus 7 cos y minus 2 equals 0. Rearrange this, 4 cos square y minus 7 cos y. Now 4 minus 2 is 2, so positive 2, I bring over is going to be negative 2. So we can double bracket, factorize this, 4 cos y, there's a cos y here, should be 8 and 1. So this is 8 and 1, so it's a minus and plus. So you get negative 7 in the middle. So it's negative 1 over 4 and positive 2. Now remember, sine and cos has a maximum value of 1, minimum value of negative 1. So anytime you get a value more than that, you're going to ignore this. Yeah? Ignore this. Yeah, we know that cos y must be between negative 1 and 1. It cannot be more than that or less than negative 1. So only one answer. So use your calculator, find your reference angle. In this case, what would it be? Reference angle y. I think you get, if you type in calculator, you get 75.5. Always remember angle in degree, 1 decimal place, and cos is negative in quadrant 2 and 3. So I'm going to take 180 minus 75.5, 180 plus 75.5. So this will be 104.5. And the second answer is 255.5. Okay, that's all. Okay, for self-test 46. Okay, so notice this time, now you may say that both of them have square. So which one do I use? Both sine and cos has square. So what should I do? Well, I know I have a term without square involving sine. So it's better for us to change everything to sine. Otherwise, if you change your cos, then you have to change back, right? So I'm just going to keep the sine square here. Don't bother about the sine square. But this cos, I change to 1 minus sine square. Then you plus one more sine. Okay, then multiply inside 2 minus 2 sine square x plus sine x. Okay, I'm going to rearrange it. Bring everything to the left, so you get 3 sine square x plus, okay, it's not going to be plus, it's going to be minus here. So this is minus sine x, then you minus 2. I transfer everything to the left, double bracket, factorize it. Okay, so this is going to give us 3 sine x plus 2 and sine x minus 1. So for sine x equals to negative 2 over 3, we have to use our calculator, reference angle. Now, your reference angle, if you use a calculator, shift sine 203, you should get 41.8, right? And since this sign is negative, so we have to take answer is quadrant 3, 180 plus, and quadrant 4, 360 minus. For positive, we take quadrant 1 and 2. Remember that. So it's 221.8 and 318.2. For sin x equals to 1, again, I'll use a graph. This is the easiest way to find the value. So you can see from the graph, your x value is 90. So all in all, you have 1, 2, and 3 answers. Okay, for the second one, I think it's easier because there's only one term with square. In this case, it's sine. We change it to what? 1 minus cos square. Yeah? Okay? Sorry. There's a minus 1 here. This is minus 1 equals to cos x. Then you expand this, 5 minus 5 cos square x minus 1 equals to cos x. Rearrange it. When I rearrange, I get 5 cos square x plus cos x. This is positive 4. Bring over negative 4. So what is your factor? 5 times 4, 20. So it should be 5 cos x. This should be cos x, 4 and 1 plus and minus. So my cos x is either 4 or 5 or negative 1. Again, for number that's not 1 or negative 1 or 0, we have to use reference angle calculator. So my reference angle in this case, if you shift cos, you should get 36.9. 1 decimal place will do. So this cos is positive, so quadrant 1 and quadrant 4, 360 minus. Okay, now this 360 minus will give us 3 to 3.1. For cos x equals to negative 1, we sketch a graph. 1 is over here, negative 1 is over here. Move it across, move it up. We can see this value is 180. Okay. involving tangent. Yeah, this is tangent and secant. So you can see this is secant square, right? We know that from the second formula for basic identity, 1 plus tangent square is secant square. So again, we change the 1 with square. Now who's having square now? It's secant, right? So we put 1 plus tangent square x minus 1. Rearrange it. Tangent square x minus 2 tangent x minus 8 equals 0. Okay. Right. So can we factorize this? What's a common factor? We should use 4 and 2, right? So tangent x, 4, 2 minus plus. So tangent x is either negative 2 or positive 4. Now for tangent x equals negative 2, use your calculator, reference angle, shift tangent 63.4. For tangent x equals 4, reference angle, use your calculator, shift tangent 4, 76.0. Now tangent is negative in quadrant what? Quadrant number 2 and number 4. So we take 180 minus 360 minus. Okay, for tangent x equals 4 is positive, so it's quadrant number 1 and 3. Quadrant 1 76.0, quadrant 3 180 plus. So you don't really have to arrange it in order. You can just subtract and write in this manner. 296.6, this is just 76.0, 256.0. Okay, that's all. Let's move on to self-test 47. So here, same thing like just now, we have a formula involving tangent and secant. So we go back to 1 plus tangent square is secant square. So tangent square is secant square x minus 1. Remember, we changed the one involving square. Okay. However, this one is y. Just take note. We instead of using x, we use y. So this will be secant square y minus 1 minus secant y minus 1 equals 0. So what we have here is a quadratic equation involving secant. So rearrange them. Secant square y minus secant y minus 5. Okay. So again, it's quite similar. The factor is 20. So feels like we've done it before, right? 5 and 1 minus and plus. So secant y is either 5/4 or negative 1. But we cannot find secant from the calculator. Remember, calculator can do sine, cos, tangent. So we have to invert this as in we change this to cos 4/5. And this will be cos negative 1. That's still the same. 1/-1 is still negative 1. So shift cos 4/5. Your reference angle is in radian now. Yeah, use your calculator, change it to radian, 0.644. And the second one, okay, I'll handle the second one later. So this cos is positive. Cos is positive in quadrant 1 and 4, sorry. So my first answer is 644, no problem. Second answer is 360 minus, but 360 we have to use 2 pi minus. So you use your calculator, you should get 644 here and 5.64. Yeah, please use 3 significant figure. For cos x equals negative 1, again we use a graph. The graph of cos is this. Yeah, is at negative 1 at 180. In 180, we convert it to pi. So maybe I write down this way. I write separately, y equals to pi. So you have 1 answer here, 2 answers here, total 3 solution. Okay. Example 48. Okay, so in this example, so we have an equation 3 cotangent square plus cosecant. So I can say that I can tell that we have to use the cotangent square plus 1 formula. Cotangent square plus 1 plus cotangent square equals to cosecant square x, or in this case cosecant square y. Now this is the third formula for basic identity. So we're going to sub inside. But before I sub inside, I bring this over first. Yeah, because I can see the one having square is cotangent. Yeah, so we're going to change the one with square. So this will be times inside cosecant square y minus 1 plus 8 cosecant y equals 0. So as you expand, this is 3 cosecant square y minus 3 plus 8 cosecant y equals 0. Just simplify this. 3 cosecant square y plus 8 cosecant y minus 3 equals 0. 3 times 3 is 9. What's the factor? 9 and 1. So to get 8, I must use 9 and 1. Okay, so this will be a plus and a minus. So my cosecant is 1 over 3 or negative 3. But you got to invert this. Cosecant is 1 over sine, so I invert the left, invert the right. So you get sine. This is 3 over 1. 3 over 1, which is 3. Whereas the second one, when I invert this, I get negative 1 over 3. Now again, sine and cos, like I said earlier, is always between negative 1 and 1. So we have to ignore this. Yeah, we have to ignore any number more than 1 or less than negative 1. So we are left with sine y equals negative 1 over 3. So use your calculator. In this case, it's in radians. So your reference angle, shift sine 1 over 3, you get 0.340. Okay. Calculator, this will be, sine is negative, right? Negative in quadrant number 3 and 4. Quadrant 3, I should take 180 or pi plus 0.340. Quadrant 4, 2 pi minus 340. So my y value is 3.48. Okay, sorry, this is radian. I shouldn't put a dot there. And 5.94. Yeah, in radian. Okay. Okay, self-test 48. Now, here you have equation, again, involving cosecant and cotangent. Now, we know that 1 plus cotangent square x is cosecant square x. So I can change the 1 with square, in this case is cosecant, right? So we have 3 cotangent x plus 2, 1 plus cotangent square x equals 7. Just expand the bracket, so 2 plus 2 cotangent square x equals 7. Put it together, 2 cotangent square x plus 3 minus cotangent x minus 5 equals 0. I think we can factorize this quite easily, right? So 2 and 5 is going to be 10. So I put 5 here, 1 here, plus and minus. So my cotangent x is either negative 5 over 2 or 1. Okay, now for your cotangent, right, we got to convert to tangent. Remember, you can only use sine, cos, or tangent from your calculator. So we cannot, read tangent from calculator. So you have to invert this. This will be negative 205, and this will be 1. Okay. For both, you got to use reference angle. You have to use a calculator. Reference angle is negative. In this case, calculator, what do you get? 21.8, right? Yeah, 21.8. But take note, this angle is only between 0 to 180. Yeah? So anything more than that, we ignore. And this tangent is negative. Tangent is negative in quadrant number 2 and quadrant number 4. But since I only want up to 180, so there's only one solution for that. Yeah, so it's 180 minus 21.8, which is 158.2. Okay, as for 40, this tangent x equals 1, we know the reference angle is 45, and it is positive, so we can only take answer in quadrant number 1, right? Since x is between 0 to 180 only, so we write our answer as just 45. So all in all, you have two answers, 158.2 and 45. 49, sorry. Example 49, find, correct to 2 decimal places, the value of y between 0 and 6 radian that satisfy this equation. Okay, when you say between 0 and 6 radian, right? Now, 6 radian is approximately 2 pi. We know 2 pi, if you use your calculator, 2 pi, right? Type your calculator, 2 pi is approximately 6.283. 6.283, yeah? So we can just think one cycle, one cycle, which is 4 quadrant. Okay, number one, what can we do with cotangent? I can see that cotangent is cos over sine. I can change that first. Then I have a 4 sine y on the right hand side. So what we can do is we can multiply the sine over, so you get sine square. And remember, whenever you have sine square and another cos, right, we change the one with square. We know sine square is 1 minus cos square, right? 1 minus cos square. So when you multiply inside, you get 4 minus 4 cos square I can bring this over, right? The problem is I think you cannot factorize because 4 times 4 is 16. Factor of 16 is not ever going to give us 7. So we have to use quadratic formula. Yeah, so when you use quadratic formula, it's negative b plus minus square root b squared. 7 squared, right? 49 straight away. 4ac, a is 1, sorry, a is 4, c is negative 4. So divide by 2a. And this one, when you type in calculator, 49 plus 64, 113, divide by 8. Okay, so you need to type this in your calculator separately because of the plus minus. Okay, type 1 by 1. The negative 1 will give us negative 2.204. The positive 1 is 0.4538. Yeah, as I say, you must do this and this separately. Type in your calculator and preferably give your answer at least 4 significant, so that when you shift cos and shift sine, you can actually find out the answer. Yeah, more accurate answer. By the way, as I said earlier, again, cos can never be less than negative 1 or more than 1, so we ignore this answer. We take the second answer, use your calculator, reference angle, shift cos 0.4538, you should get 1.1, right? And this cos is positive quadrant 1 and quadrant 4. So I think I'll just take the first one straight away. Don't write reference angle. Second answer is 2 pi minus 1.10. So 1.10 and 5.18. Yeah, 2 answers. Alright, self-test 49. So here we have 6 cos x equals to 5 tangent x. So we can change the tangent to sine over cos. So this is 6 cos x equals to 5 sine x over cos x. So let us multiply over, so you get cos square x. This is 5 sine x. Now remember, the one with square, we have to change it. So cos square is 1 minus sine square. As I multiply inside, this is what we will get. Okay, what I have to do is to rearrange the equation. So 6 sine square x plus 5 sine x minus 6 is 0. Okay, I think again you cannot factorize. Can you? I'm not sure. 6 times 6, 36. 36, 9 and 4. Yes, you can factorize. 9 and 4. So this will be 3 sine x, 2 sine x. To get 9, must put a 3. To get 4, must put a 2. 1 must be a plus and a minus. So sine x must be 2 over 3 or negative 3 over 2. Again, we know sine cannot be less than negative 1. So I don't have to write that anymore, right? So just straight away write it. Yeah, reject this answer. Use your calculator. This time is in degree, 0 to 360. So reference angle, shift sine, I think you should get 41.8. And the second answer, because sine is positive here, quadrant 1 and 2, remember, ASTC. So 180 minus 41.8, this will give us 138.2. Okay, so 2 answers, 1 and 2. Alright. Okay, example 50. So here we have cosecant and cotangent. So cosecant is 1 over sine, right? And you have cotangent, which is cos over sine. Okay, so what I can do next is to get rid of fraction and multiply everybody by sine. Okay, as I multiply by sine, this will be 1 equals to sine square y plus cos y. Now again, you have a problem. We have an equation involving sine square. So what do? We change this to 1 minus cos square, right? So next, we multiply inside 2 minus 2 cos square y plus cos square y. So this is going to be negative, right? Negative cos square y. So I transfer over, I get positive cos square y. Yeah? Okay, I made a mistake here, did I? Okay, there's a single cos, sorry, there's a single cos here. No square, sorry. No square, so let me do some changes here. Okay, I can just bring this over, right? This is going to be 2, alright? And minus cos y minus 2 equals 0. Let's double bracket factorize it. So can we factorize? Ding, ding, ding. Cannot. I made a mistake here. There's a 1 here, right? There's a 1 here. So when I bring over, it's going to give us -1, right? So yeah, we can factorize. Okay, so this will be 2 cos y, 1, 1 minus 1 plus. So my cos y is either -half or +1. So with that, now if you shift cos 1/2, if you use your calculator, your reference angle is 60. But this cos is negative. Negative means quadrant number 2 and 3. So, and this is in degree, so we can say y is 180 minus 60, 180 plus 60, quadrant 2 and 3. So this will give us 120 and 240. As for cos y equals -1, use a graph. +1, sorry, is between 0 and 360. But take note, can you see it's non-inclusive? Pay attention to this, non-inclusive. It does not include 1 or -1. So we cannot take any answer. Yeah, there's no answer for this. Yeah, no solution for here, because if you put 0 and 360, they are both out of bound, right? So only a pair of answer, 120 and 240. Okay. Okay, self-test 50. All right. So find all the angles between 0 and 360 such that 3 cos y plus 2 secant y is equals to 2 tangent y. So what can we do? We can start by changing secant to 1/cos and tangent to sin/cos. Okay, so let's start at 3 cos y plus 2 over cos y equals 2 sin y over cos y. Okay, the next thing is we got to get rid of fractions. So I'm multiplying everybody by cos. So 3 cos square y plus 2 equals 2 sin y. Again, we change the one with square. In this case is cos square. We change to 1 minus sin square. We have a lot of these, right? You may find that, this is automatic. After some time doing this, you can close your eyes and still do maths. Okay, I'm not sure whether you can do that. Rearrange for me. 3 sin square y plus 2 sin y. This is 5. Bring over is -5. Okay. All right. Now, what can we do? Factorize. So, double bracket, 3 and 5, 15. 15 should be 3 sine. This is a single sine. Should be a 5 here, 1 here, plus and minus. Okay, so sine y is -5 over 3, or sine y equals to 1. Now, here's the good news. I cannot take this as answer, because like I say, sine is always between -1 and 1. Anything more than that, we ignore. So only one answer. That makes our life easier. So 1 is over here. It happens when y is 90. Yeah, therefore only one solution. Okay. Okay, in example 51, so here we have equation involving cos square and sine square. So I'm supposed to show that tangent square equals 1/12. So for me, we can change either everything to sine or everything to cos, whichever easier for you. So for me, maybe I change everything to sine. So I will start by writing cos square as what? 1 minus sine square. So you minus 3 sine square theta equals to 9. So multiply 10 inside. Alright, so what we have here is 13. Maybe I do a bit slower here. 13 sine square theta equals to 9. Bring over to the right hand side by rewrite on the left. 10 minus 9 is 1. So your sine square is 1/13. So here we have two ways of doing it. Either you write this as a square root, 1/13. Draw a triangle. Now, sine is a ratio of opposite over hypotenuse. My adjacent will be root 13 square minus 1 square square root, which is root 12, right? Now, with that, I can find tangent, right? So, tangent theta is opposite, which is 1. Adjacent is root 12. But the moment you square it, then you will get 1/12. Okay. Now, alternately, you can also do this way. Since I've got my sine square already, so from here, I've got my sine square already. So we can say that cos square is 1 minus sine square, 1/13, which is 12/13. And tangent square is my sine square, 1/13, divide by cos square, 12 over 13, which is still 1 over 12. Yeah, up to you. You can use this method instead of drawing a triangle out. Okay, B. Now, how do you solve this equation? We just use this whole result, which is tangent square equals to 12. But whenever you square root, please put a plus minus 1 over 12 and use your calculator. Okay, if you work it out, your theta will be what? My theta, my reference angle, and this is in radian, so I'm just going to write a reference angle, it's in radian. So my reference angle is 0.281. Now, notice that angle is only up to quadrant 2, and because of the plus minus, I have to take 1 and 2, both answers. Quadrant 3 and 4 is out. So my first answer is 0.281. Second answer is pi minus 0.281. Therefore, you will get 2.86. Always give your answer correct to 3 significant figure. Self-test 51. So now, again, we have to change everything to either sine or cos. It's up to you whether you want to change to sine or cos. Maybe you just change to sine. Sine is, you're more familiar with sine, right? So we change the cos to 1 minus sine square. Okay, so that's the first step. Then as you expand, you get 2 minus 2 sine square x plus 1. Bring over, you get 5 sine square x equals to 3. Sine square x is now 3 over 5. So when you square root, you should get, okay, sorry, I just square root straight away. Don't have to write this. Root 3 over 5. You can write root 3 over root 5. Root 3 over root 5. Okay? Alright, if you don't want to use this, maybe you can just use cos square straight away. I think it's easier. Cos square is 1 minus sine square. So it's just 2 over 5. Yeah, don't bother doing this. If you don't want to do this, don't bother. So tangent is basically sine divided by cos, which is just 3 over 5. 3 over 2, get rid of the fraction, 3 over 2. Okay, I don't like this, just rub this off. Okay, so there you go, 3 over 2. And how do you solve for part B? Very easy. Use this result, square root this. Whenever you square root, please put a plus minus root 3 over 2, right? Reference angle. My reference angle should be 50.8. Now, because x is between 0 and 360, so we have to consider all four. Tangent is positive in quadrant 1 and 3, negative in quadrant 2 and 4. So all four answers should apply. 50.8, first one. Second one, 180 minus 50.8. Third one, 180 plus 50.8. Last one, 360 minus 50.8. So with that, I got four answers. First, second, third, and last answer. Okay, there you go.